What's up YouTube, this is Navan Gujral, and today this video will be about natural language processing, but more specifically, what the SEQ2SEQ training model is, how it works, and how to train it. Hope you enjoy the video. Recently, I created a chatbot that uses the SEQ2SEQ training model. Later in this video, I will be explaining how the SEQ2SEQ training model works and how to train it. But right now, this is the overall and end product of the chatbot that I created. And as you can see in the chatbot, it keeps the conversation going as you can ask questions. You can also talk back to it, and it will do the same to you. In order to understand how a SEQ2SEQ training model works, we need to first understand how a neural network works. The neural network has three main parts: the input, the hidden layers, and the output. The input are the values that you give to the neural network for it to do an action. The hidden layers are the actions themselves, and they work by using the values that are given by the inputs. Then after the action has been taken place, all those values will be put into the output, and that is what is given out of the neural network. Now let's look at the SEQ2SEQ model itself. So this is what a SEQ2SEQ model would kind of look like. The SEQ2SEQ model has three main parts. The first part, which is in green, is the encoder. The encoder is the input that you give in to the SEQ2SEQ model. The blocks in blue represent the decoder. The decoder is the output, and it gives out what the chatbot is going to say to the person. And the last block in orange is called the EOS, which stands for end of sentence. What happens with the EOS is that in the green blocks, each of them has a word to it. So if the first green block could have hi, the second green block could have is, and so on and so on. And the EOS takes all of those values from the words, from the encoder, and stores it into the EOS for then to give out to the decoder. Another important part are these arrows, which are called synapses. Synapses transfer the signals and values from one of the neuron to the other neuron. And each of these synapses has a weight. So what do these weights do? So imagine if each of the neuron is like a train station. The first train station is the green circle, and the second train station is the orange circle. Both of these train stations are connected by a train track, or we're going to call it the synapse. And in each of this train station, values go through it, which are the trains. As the trains go through, there are a lot of values going through the train track every time. So in order to not let it overflow, what happens is that the values filter through and make only the important values go through. So if 2 is going to be filtered out, then only 1 and then 3 will go, and then 2 will just stay at the station. So now that we know how the SEQ2SEQ training model roughly works, let's see it being used for a sentence. So let's take this sentence. What does a sentence mean? And see what would be the output, and then how would it work. So what it would first do is split it up between every word. So what does a sentence mean entirely would then turn into the singular word what, then does, then this, then sentence, then mean, and even the question mark would also be considered a different word because punctuation and anything that is separate would also consider part of the word. Then all of these will be put into the encoder. So what does and this have their own separate neuron that they're attached to. And then there's so on and so on for all of the words. Then all of these values are then combined into the EOS. Then what happens next is that the decoder looks at this sentence, then tries to figure out which of the sentences they can make. So it would make multiple of the sentences and then find out the best one that would fit. So then the output of the EOS would be the, because it thinks the is the highest likeliness of the word that would come next. Then the will be fed into the next neuron. And then it would see what would come after the. And then it figures out the meaning should come after the. And then so on and so on until it forms the full sentence that it's going to give out. So how does this model get trained? For my training model, I use movie lines. And these movie lines all have a question and then an answer. So let's look at the two lines boxed in red, which is the question is she okay? And the answer is I hope so. So then what would happen is that the question, each of the words would be fed into the encoder. And then all of those values from the encoder will then go into the EOS. Then what it would do is that it would have weights to it to figure out which of the values are important for it to go through. And then it will try to figure out which of the words is the most important for it to give out and the highest probability. So EOS would give out okay as the highest probability word that is supposed to come next after she okay. And then okay would then go into the next neuron's input. And then it thinks that period should come after okay because it's the next highest probability of that coming after okay. And then after period, it thinks that it should be the end of sentence. So that's the highest probability of that to come next. So then it would put it as the end of the sentence. So after it gets an output from the SEQ2SEQ model, it will then compare the output to the output that is supposed to come out. The output in this case was okay, period, and the output that was supposed to come out was I hope so. And these do not match. So what happens? It then figures out the cost function. The cost function is the error that takes place in the data. So if the output value was this in the yellow box and the actual value was the green box, the cost function, there would be a cost function because they do not match. But if the output value and the actual value do match, then there would not be a cost function because there was no error that took place. But if an error did take place, what would happen? What would first happen is that the cost function would then be sent back through the data. What would happen is that the cost function will be sent back through the CTC training model. And then what it would do from there, the CTC training model would then make changes to accompany this. And the change it would make is it would change the weights. In this case, it changed the weights from 1 to 2. and then it will test it again. In this case, the output came to be I hope so. And I hope so does equal to I hope so. So that means there is no cost function because there is no error. So that means this is good for training. In the CTC training model, there is a special type of way that you have to put in the words. So if you want to put in the word hello, that's simple for us humans to understand, but for a computer, it's not so much. What you would need to do is give it a special identifier. For example, let's give this special identifier for hello 1, 2, 3, 4. So whenever we want to put the value hello, we have to say in brackets 1, 2, 3, 4. Let's try and put this words into how the SEQ2SEQ training model would take in the values. First, it would take hello as 1, 2, 3, 4, my as 3, 5, name as 7, 5, 8, 2, so on and so on. Thanks for watching the video. I hope you enjoyed this video. If you enjoyed the video, please make sure to like the video, and if you're new, please consider subscribing. If you want to see more content just like this, please check out this video right here. And if you want to see more and my new videos coming up, please consider subscribing to the channel right here. Thanks for watching, and see you guys next time.